I'd like to show you how to run a multiple regression. In order to do that, I use the same 30 observations I've used previously in my simple regression setup. And now I'm going to choose from the data analysis toolbox the regression again. The input range is the same as before, the sales price. And the X range now consists of all the explanatory variables I want to take into account. Of course, this has to be a well-informed choice. In terms of Excel requirements, it has to be noted that you have to put all the X variables right next to each other. There must not be any gaps in between. You cannot work with a control and select function. So they must be in a block of data. Otherwise, you would have to rearrange that. So I'm using at the moment the quality, the condition, the year built, and the living area. I have included the labels in the range, and the output I will put here. And what I get now is, rather than before, where I only got one slope with respect to the living area, which was 18.6. I now have 4 explanatory variables, and the important thing here is that each of the 4 slopes that I get measure a so-called net contribution to the expected price. So we could interpret those numbers, for instance, as if the quality changes by 1 notch from 6 to 7, and all the other criteria stay the same. So in other words, I'm comparing 2 houses which are exactly the same, except for one explanatory variable differs by 1 unit. Then the expected price impact in this case would be 7,700. Now to help you even more to understand what's going on here, I'm computing the fitted values again. This time we have 4 explanatory variables, so we need to take products of each coefficient with the corresponding value in the data range. So I'm starting with the constant term. I fix that by pressing the button F4, and then I would have to take the coefficient of the quality, which I fix, times the quality, which I don't fix, because this is going to change for every row. And then I take the coefficient of the condition, fix it by pressing F4, times the condition for this particular house. Then the year built coefficient times the year built for this house, plus the living area coefficient times the living area for this particular house. So this will be the expected price for this particular house, given the average, given the overall picture from all those houses. And these will be the fitted values or expected values for all those houses. Now let me just, in order to interpret, help you again to interpret these numbers, suppose we would now consider a house which is the same as this one, except for the overall quality has a value which is 7 rather than 6. Then the difference in the fitted value is exactly the coefficient that we have here. Or if we increase the overall condition, or decrease the overall condition for that matter, by 1 unit, then the drop is given by that coefficient here. If the house has been built 1 year earlier, we get this coefficient here in the expected value, and if the house has square feet which are, let's say, 100 square feet, 100 square feet less, then we would get a price increase of 100 times this coefficient. So it's important to remember that these four coefficients measure the net contribution, holding the other explanatory factors constant.